Hello. 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 Good afternoon, student. Today we will discuss about state variable analysis. There are two methods to analyze or design a system. First method is classical method and second is state variable method. In classical method, we have studied about root locus, polar plot, Nyquist plot and Bode plot. All these are based on transfer function. We have already studied about root locus, polar plot, Nyquist plot and Bode plot, and all these methods uses transfer function. So classical method is also known as transfer function based method. Shubham, Vikas, hello. Then limitation of classical method valid only for linear time invariant system. Means classical method is used only for linear time variant systems. We can't analyze variant system or non-linear system using classical method. Second disadvantage of classical method is it is valid only for single input and single output system, and it does and this method does not describe internal state of system. Internal state of system means initial values of system or initial states of system. So in classical method, initial states of system cannot be described, and we always take initial condition 0 in classical method. It gives the zero state response. Zero state response means it depends, output depends only upon input. Output doesn't depend upon initial states of system. Suppose this is time variant system and we give input x of t, and here we get an output x of minus t. So we can say that yt is equal to x of minus t, and this is time variant system. If we take Laplace transform of yt, then if we take Laplace transform of both sides, then we get y of s is equal to x of minus s, and y of s divided by x of s is equal to, we get transfer function. So in this case, y of s, we cannot get y of s divided by x of s. So for the transient system, since we cannot calculate transfer function, so classical method or transfer function method is not able to analyze time variant system. Similarly, for non-linear systems, if we give an input x of t, and here we get y of t is equal to x squared, because non-linear system. And if we take Laplace transform of both sides, then we get y of s is equal to x of s convolution x of s. In this case, we cannot calculate y of s divided by x of s, which is transfer function. So, since we cannot calculate transfer function of non-linear system, we cannot use transfer function method mm, or classical method. to analyze the non-linear system. So we can say that classical method is not valid for time variant or non-linear system. Then next is state variable analysis. State variable analysis is valid for linear, non-linear, time variant, time invariant system. And it is also the advantage of state variable analysis is it is valid for single input, single output, and it is also valid for multiple input and multiple output system. Describe the and this state variable analysis describe the internal state of the system. Means it takes the internal state means initial states, initial values of system. So it describes the internal state of system. It provides zero state response. Zero state response depends only on input, while zero input response depends upon initial state and input. Means it provides both zero state response and zero input response. State space analysis. dx by dt is equal to a x of t plus b u of t. This is known as the state equation, and y of t is equal to c x of t plus d u of t. This is output equation. Then we find out what is dx by dt, what is u, y, a, b, c, and d. dx by dt is state vector of order n cross 1. Similarly, u is input vector n cross 1. Order of input vector is n cross 1, and y is output vector. Order of output vector is p cross 1. Okay. Then x is n cross 1. Order of this vector is n cross 1, and x is state vector. X is a state vector, and order of this state vector is n cross 1, where n is the number of state variables. State vector x is a collection of state variables. Means in this case, state vector is a collection of state variable. Input vector is a collection of input variable. Output vector is a collection of output variable. So this in this case, x is a state vector, and this state vector is a collection of state variables. Okay. Then number of state variables. Number of state variable is equal to number of initial state. States are initial values. So number of state variable, number of initial values, or number of initial states, or order of transfer function, or order of differential equation. If suppose that value of n is 1, means there is only one state variable, then we can write x is equal to x1, and order is 1 cross 1. When there are two variables x1 and x2, then we can write x2 cross 1, this is the order, and here we write x1, x2. If there are three variables x1, x2, x3, so this state vector is written as x1, x2, x3. State vector is generally column vector. Then here dx by dt, and this is differential state vector. Differential state vector is a collection of differential state variable. State vector is a collection of state variable. Differential state vector is a collection of differential state variable. Here, u is a vector And order of this vector is n cross 1 and n is the number of input variables. Input vector, and this input vector is a collection of input variables. Similarly, y is output vector and order of this output vector is p cross 1 where p is the number of output. Output vector is a collection of output variables. A is n cross n system matrix and this B is n cross m input matrix. C is output matrix. Here n is the number of input, P is the number of output. So suppose that this is a system and here we give input. If there are m input, we get a input vector. Order of this input vector is n cross 1. We get an output vector and order of this output vector is n cross 1 and these are the initial values or system states and these are the state and these are the limitation of conventional method or classical method. Advantage of state variable analysis. This method takes into account the effect of all initial state. This can be applied to nonlinear as well time varying system. It can be conveniently applied to a multiple input, multiple output system. Can be designed for optimum or optimal condition precisely by using their modern theory. Any type of input can be considered for the design of system. This method involves matrix algebra because we use system vector, input vector, output vector. So it can be conveniently adopted for digital computers. The state variable selected need not necessarily the physical quantity of the system. And the vector matrix notation generally simplifies the mathematical representation of the system. Concept of state. The states are nothing simply initial conditions of system. Suppose in this network, if we want to find out output and here resistor and capacitor is connected, then this input is not sufficient to calculate the output because of presence of capacitor. Capacitor is an energy storage element, means there is some initial voltage across this resistance. So we can say that in this case, output depends upon input and initial states of system, means initial values of system. So output in this case depends upon input and initial conditions of system. And thus initial conditions describe this. So we can say that initial conditions describe the state of system at t is equal to t naught. T naught may be 0. We can assume that this may be 0 or anything. So initial conditions describe the state of system at t is equal to t naught and state can be regarded as compact and concise representation of past history of means state is you can define state as the initial conditions of system or you can say that states are past history of system. So state of system contains all the information concerning the past history of system required to determine the response of system for any given type of input. Then in this part we define state variable, state vector, and state space. State. The state of a dynamic system is a minimal set of variables, and knowledge of these variables at time t is equal to t naught together with input. Means if we know initial conditions and we know input, then we can determine the system behavior for any time t. The state of dynamic system is a minimal set of means state of dynamic system is a set of variables, and knowledge of these variables means state is a set of variables, and these variables we know these variables at time t is equal to 0, and together with input t is equal to or greater than t naught completely determines means input and initial state completely determines the behavior of system for any time. Then state variable of a dynamic system are a minimal set of variables which determine the dynamics of linear system. In a state variable for x1t, x2t, these are the state variables, and x1t naught, x2t naught, these are the initial conditions. And once we know the initial state and input for time t is equal to t naught or greater than t naught, then we determine the future behavior of system. One example, next is state space. The state space is n-dimensional space whose coordinate axis consists of x1 axis, x2 axis, xn, x3, xn axis. Any state can be uniquely represented by a point in the state space. This is the three state variable in three state variable x1, x2, and x3. These are the three axes. In n space, n state space, there are n axes. State model representation for linear system. State model representation for linear system. To represent a state model of a system, the state variable are generally represented by, if you want to represent a state model for a linear system, these are the inputs u1, u2, um. These are the input variables,